We will now work out with the second problem of finding a bilinear transformation that maps the points 1, 0, minus 1 in Z plane onto I infinity 1 in W plane. Here the difference is that you have infinity as a point. Usually in the complex plane, infinity is represented as a point on the north pole. So what I have to do is I have to find a transformation that gives the images of 1, 0, minus 1 as I, infinity and 1. And if I want to find the bilinear transformation, I should remember the cross ratio formula. I'll have like this: W minus W1 into W2 minus W3 by W minus W3 into W2 minus W1. This is equal to Z minus Z1 into Z2 minus Z3 by Z minus Z3 into Z2 minus Z1. Okay. So now what I do is I'll take the points 1, 0 and minus 1 as Z1, Z2, Z3, and the points I, infinity and 1 as W1, W2, W3. And here you can see that W2 takes the value infinity. But when I substitute W2 is equal to infinity in the left hand side, I will have infinity by infinity form, which is indeterminate. But somehow I have to calculate the bilinear transformation. So what I will do is I will make a suitable adjustment here. I will remove W2 as a common factor in the numerator. That will give you 1 minus W3 by W2. And similarly, I will also remove W2 as a common factor in the denominator. That will give you W2 into W minus W3 into 1 minus W1 by W2. Okay. I will retain this term on the right hand side as such: Z minus Z1 by Z2 minus Z3 divided by Z minus Z3 into Z2 minus Z1. This W2 gets cancelled, and when I substitute W2 is equal to infinity, this part will become 0. W3 by W2 will become 0, and W1 minus W2 will also become 0. So I will have W minus W1 by W minus W3. This is equal to Z minus Z1 into Z2 minus Z3 whole divided by Z minus Z3 into Z2 minus Z1. So I will have W minus I by W minus 1. This will be Z minus 1 into 0 plus 1 by z plus 1 into 0 minus 1. Okay. Now what I will do is I will simplify this. I'll have w minus I into minus z minus 1. Okay, I'll multiply diagonally w minus I into minus z minus 1. This is equal to w minus 1 into z minus 1. Okay, w minus 1 into z minus 1. Okay, now when I multiply the terms, okay, I'll have like this w. So what I have to do is I have to multiply the terms w minus I into minus z minus 1 and equate it to w minus 1 into z minus 1. Okay, this will do it in the next page. Okay, so now what I have to do is let me again rewrite this. What do I get? When I rewrite this, I'll have w minus I into minus z minus 1. This is equal to w minus 1 into z minus 1. So I'll have minus wz plus iz minus w plus I is equal to wz minus z minus w plus 1. Okay, as usual what we do is I will put the terms containing z on one side, iz plus I retain these two terms. I bring these two terms to the other side, plus z minus 1. I'll bring these two terms. Okay, now what I will do is I will retain the terms like this. Wz minus w, these two terms are retained, and when I bring the other two terms I will have plus wz plus w. Okay, oh, here plus w and minus w gets cancelled here. So when I simplify this, I will have like this, I into z plus 1 plus z minus 1 is equal to 2wz, or w will be I into z plus 1, I into z plus 1 plus z minus 1 whole divided by 2z. So this will be the bilinear transformation. Okay, if I want I can also write this as 1 plus I into z. That is, I take z as a common factor. iz plus 1 I can write it as 1 plus I into z. I'll have plus I minus 1 plus I minus 1 whole divided by 2z. Okay, either you can stop here or you can write it in the form az plus b by cz plus d. Here of course d is equal to 0. So this will give you the bilinear transformation. But you have to keep note that if one of the terms contain infinity, say w2 is infinity, you remove w2 in the cross ratio formula, and when you have 1 by w2, automatically it will become 0. This completes the problem.